Doing problem 1, section 7.4, 3 definite integrals. We'll do these a little faster. Antiderivative here, negative 1/3 x cubed. Antiderivative here, 3/2 x squared. Antiderivative of the last one, 5x. Evaluating this from minus 3 to 2. Plugging in minus 3, 1/3 x, or oops, 1/3 minus 3. Sorry, plugging in 2 first. 1/3, 2 to the third power, minus 3/2, 2 squared, plus 5 times 2. Subtracting off what we get when we plug in negative 3, so minus 1/3 times minus 3 cubed, minus 3/2, minus 3 squared, and plus 5 times minus 3. Okay, if you put all this together, you should get 125/6. Okay, the second one, we can rewrite this thing as as a power function, so we can use the power rule. So let's write this as 3x to the minus 3 power minus 5x to the minus 4 power. Okay, so the antiderivative there, raise that by 1, we get minus 2, so we're going to get minus 3/2 x to the minus 2. We get minus 5/3 x to the minus 3 power, and actually that should be plus since we're dividing. So if we raise that to a minus 3 power, then we're also going to be dividing by negative 3. That's why this becomes plus. So plus 5/3 x to the minus 3. Evaluating this between 2 and 3. And if you like, you can change this back to having positive exponents. So we would get minus 3/2 x squared plus 5/3 x to the third power. Evaluating that between 2 and 3. However you want to do it, at the end of all this, you should get 5/81. That's plugging in 3 here and here, plugging in 2 there and there, subtracting the two answers that you get, and once you simplify that, you should get that. For this last one, we're going to do a substitution. We're going to let u be equal to 2x plus 1, so that makes du 2 dx. We've got a negative 3 up there. Let's go ahead and do it this way. We're going to divide by 2 here, so we'll get 1/2 du is equal to dx, so that the integral then becomes, we'll have a 1/2 in front here, so 1/2. This minus 3, we'll just leave it. In fact, actually probably better just to put that on the outside. Let's go ahead and do that. We'll say minus 3/2. Again, that 1/2 is coming from the dx. The dx here is going to change to 1/2 du, so there's the 1/2, and the minus 3, we're just putting it in front there. Okay, so after that, then what are we left with? We took care of the dx, we moved the negative 3 in front, so what are we left with? 1/u squared, and there's the du. And then we have to change the bounds as well based on the substitution. The lower bound was 1. If I plug in 1 there, 2 plus 1 is 3, so my new lower bound is 3. I plug in my old upper bound, 4 times 2, 8 plus 1 is 9, so my new upper bound is 9. To do this antiderivative here, we have to change this to a power function. So let's change this to u to the minus 2 power. Okay, antiderivative will raise that by 1. That because it gives us a negative 1. So if we divide by negative 1, the sign changes there. So we're going to have positive 3/2 u to the minus 1 power. Evaluating this between 3 and 9. That's the same thing as having 3/2 u evaluated from 3 to 9. So if you plug in 9 and you plug in 3 and you subtract the two of those, you should get negative 1/3. So remember, the definite integral doesn't necessarily have to represent an area. In fact, it only represents an area under a curve if the entire function is positive. So the fact that we're getting a negative answer here means that some or part of this function, or even all of it, is below the x-axis on the interval that we're looking at from 1 to 4.